right? So basically, let's say that f is a one-to-one function. Okay, so if s is a one-to-one function, then f is a function that is always increasing or always decreasing in its domain, right? And let's say that f is the function, in this case, I would say there is 7x minus 3. And I ask you find the inverse function of f. An inverse function of s is represented with this notation. So how do you find the inverse function of f? Well, the first would be to replace f of x by y. So I have the function, there is f of x equals 7x minus 3. So we will replace f of x by y. Then we get y equals 7x minus 3. Now we're going to interchange x and y. So where you have the y, you will now put an x. Where you have the x, you will now put a y. You will then solve for y. So we say x plus 3 equals 7. X plus 3 equals 7y. And then you will divide by 7. So we say that x plus 3 over 7 is equal to y. Now, let me just quickly fix this number here. Now, we're going to do the last step, that is where we replace y by inverse function of f. So we can say that the inverse function of f of x is x plus 3 over 7. Now, how do you know if your answer is correct? To demonstrate, that your answer is correct, then now you must show that the composition between the function f and its inverse, so f composition with inverse function of f of x needs to be equal to x, and inverse function of f composed with f of x needs to be equal to x2. So you can demonstrate that these two compositions are equal to x, then you now know that your solution is correct, that the function you found is really the inverse function of the function f. So I will now show you how we can do this composition. So we just copy the two functions we found, the function we found as inverse together with the original function. So we have f of x equals 7x minus 3. We have inverse function of f of x equals to x plus 3 over 7. And then now I will find the compositions of the two functions. So the first composition that I will find is f composed with inverse function of f of x, which is f of inverse function of f of x. So basically, we're going to plug in the function inverse function of f into the function f of x. So we will say that this is 7 times the inverse function of f of x minus 3. So it's 7 function of f of x minus 3. So it's 7 times x plus 3 over 7 minus 3. 7 and 7 here cancel out. So we have x plus 3 minus 3. And this should be equal to x because 3 minus 3 will be 0. So the first composition was equal to x, so it's fine. Let's do the next composition now. We have the composition f composed, inverse function of f, composed with f of x, which is inverse function of f of x. So basically, we're plugging in now the function f of x into the function inverse function of f. So we say this is inverse function of, function f of x plus 3 over 7, because I substitute this x by the function f of x. F of x is 7x minus 3 plus 3 now over 7. Negative 3 plus 3 is going to be 0. So we get 7x over 7. 7 and 7 cancel out. This is 1. So again, we got x. So since both compositions are equal to x, now we know that this function that we found here is really the inverse function of this given function. This is how you calculate the inverse of a function. In this topic of inverse functions, I can also ask you to find the inverse, but I can give you the function as a set of order pairs. So find the inverse of a function f given as a set of order pairs. So let's say that the function f is the function that contains the following order pairs: 2, 5, 3, 6, 4, 7, 5, 8, 6, 9. As you see, we have a function expressed by these 5 order pairs. So remember that in each of these order pairs, the first coordinate correspond to x, and the second coordinate correspond to y. So what we have to do when a function is given as a set of ordered pairs to find its inverse. Well, if the function is one-to-one, okay, and we want to find inverse, and the function is given like that as a set of ordered pairs, what we need to do is to interchange the positions of x and y for each ordered pair. Why? Because remember, from the reading of the topics in the book, that if you have two functions f and its inverse, you will see that the domain of the function f will be the same that the range of the function inverse. And that the range of the function f will be domain, be domain, will be domain of the function inverse. So the only thing you have to do if you want to find the inverse of this function is to switch the x and y coordinates of each ordered pair. So the inverse function of f in this case will be the function containing the ordered pairs 5, 2, 6, 3, 7, 4, 8, 5, 9, 6. And here we have, the function inverse. So what we had to do, we have just basically to rewrite the ordered pairs where, what was the domain of the function f. So 2, 3, 4, 5, and 6 becomes range of the function inverse. 2, 3, 4, 5, 6. What was range of the function f? 5, 6, 7, 8, 9 becomes domain of the function inverse. 5, 6, 7, 8, 9. The next there is important about a function f and its inverse is when you find the graph. When you find the graph. When you want to find the graph of the function inverse, you will have to switch again the coordinates x and y, and then you will find that the graph of the function f and the graph of the function inverse are going to be symmetric with respect to the line y equal x. Let's say there is a function f that is f of x equals 2x plus 1, and then let's say we have a function inverse that we're going to find. So we say y equals 2x plus 1, so x equals 2y plus 1, so x minus 1 equals to y, So y equals x minus 1 over 2. So inverse function of f equals of x equals x minus 1 over 2. So these two functions are inverse of each other. We're going to graph both functions, and we're going to see, if it's true that they are symmetric with respect to the line y equals x. So my first function, and I will show you now this decimal account, is y equals 2x plus 1. And the other function is y equals x minus 1 over 2. So the function you see in red is the function 2x plus 1. The function you see in blue is the inverse function x minus 1 over 2. And the line in green is the line y equals x. So the goal of showing that line in green is only to show you that the two graphs are symmetric with respect to the line. Now, I want to show you something. Look at this point. This point is 0, 1 on the function f. Then 1, 0. So we have interchange, the x and y. 1, 0 is a point on the function inverse. So 1, 0 on the function inverse, 0, 1 on the function f. Like that, you can see, for example, this one here, minus 2, minus 1.5 on the function f, minus 1.5, minus 2 on the function inverse. So this is how you graph a function f and its inverse. So you just have the different points on the graph of the function f. You switch the coordinates x and y, and then you plot those points on the rectangular coordinate system, and then you can graph, the function inverse.